We are off to sunny Stratford-upon-Avon, where we have a trip fault. The homeowner phoned me up, said I switched off the kitchen lights and everything's tripped off. Okay, well that sounds like an RCD trip if it's affecting more than just the lights. So I had him switch off all the downstream circuits and switch off the RCD. And I said, right, now switch the RCD back on and then switch the circuits on one by one, and we'll see if there's any particular circuit that trips it off, because we might be able to get some of the circuits back on. It doesn't always work like that, it depends on the nature of the fault. If you've got a neutral fault, and it's a bad neutral fault, like a resistive short, then you can have trouble getting power back on to any of the circuits. But interestingly, he said he couldn't restore the RCD even with all the downstream circuits switched off. So that's interesting, isn't it, Mr. Marsh?
It certainly is, Mr. Savoury.
That makes me think that we're looking at current coming in from neighbouring properties. I presume it's a TNS connection out there. I reckon there's currents on the earth from neighbouring properties which must be causing that. So maybe we'll get the clamp meter on there so that we can see.
After 500 metres, bear left.
We're on yet another fault mission. The mission being that the RC is stripped off in this place, out in sunny Stratford. It is sunny as well, isn't it, Nigel? Albeit cold. Get the head on camera. That's down there. Meter, TNS service. Let's get some light on the subject, shall we? We do, please, Mr. Marsh. Stop disrespecting people's property. You take that and do something useful. This is a big old board, isn't it?
It is. Oh, it's smell around here.
The usual useless label that doesn't tell you who put it in or how qualified they were to be claiming that any inspection had been made, and whatever pen or pencil they used has long since worn off. The usual Hager labels as well that adhere not very enthusiastically to the boards, but hey, people like Hager. That's a lot of circuits to be hanging off an RCD, isn't it? We got the call in to say that this RCD had tripped off, so we said, well, turn all the outgoing circuits off, then reset it, and then start turning them on to see if there's any particular one that seems to cause it to trip. Not that that is necessarily a smoking gun, because the fault could be on one circuit and the load current on another circuit, and it's all leaking through the neutral. Anyway, the fact is, will you look at that? No outgoing circuits energised, RCD won't reset, so either that's faulty, or maybe we've got some earth leakage coming in from neighbouring properties, which is causing us to not be able to reset that RCD. We'll think about that. So obviously what we've got to do here is try and work out which of these circuits has what must be a neutral fault to prevent that RCD going on unless the RCD is faulty. We can test for that, can't we? Because if we take the RCD out of the loop, so to speak, get that off there. There you go. Latches, resets. While unenergised, disenergised, non-energised. So one of these circuits, one of these outgoing circuits, has a neutral fault. Which one do you reckon it is? Let's start from the left, shall we?
Pick a neutral, any neutral.
Hello? Oh, there you go. Straight away. That's first time looking. That's all right, isn't it? So it's that one, which is that one, which is the kitchen lights. Kitchen lights. Actually, I say that was more of an educated guess. That it would be that one, because he told me it happened when he turned on the kitchen lights or turned off the kitchen lights. I don't know why I'm putting that back on.
So this is tripping with nothing turned on.
Can you put this on the earth out here? Okay, we've got a big number out here. 1.5 amps.
Wow. And there's nothing turned on in there. Do you get that? Did you turn the main isolator back on in there?
That's on in there, yeah, but everything's switched off. So that's 1.5 amps. I should have brought my HT clamp with me. 1.5 amps floating away from neighbouring properties there. What we've got is a TNS connection and put the backlight on. You can see that on the earthing, this is going around the main earthing, we've got about 1.7 amps, which is coming in from neighbouring properties. I don't know how well that catches on camera, but it's 1.7 amps. It's fluctuating around a bit between an amp, amp and a half. It's dropped to 1.4 now, but it's up and down. And that's a current on the earthing coming from the neighbouring properties. So for that RCD to be tripping with no load on, that current on the earthing must be leaking into this lighting circuit. So there must be a resistive short between this neutral and the earth bar. We'll check for that in a minute. Leaking into that lighting circuit via something that's gone faulty, which we've got to find today, causing an imbalance of this RCD, which prevents the RCD from switching on when that neutral is connected. So that fault that we're looking for, well, let's have a look for this resistive short, shall we? I'm going to fire up the Metrel MI3152, which we still have, which still belongs to Metrel, and we haven't given it back yet. It's probably going to be a little bit scratched up by the time we hand it back. Sorry, chaps. So I'm going to go into single tests resistance. No, just crap on the camera. You didn't film any of that, did you? Didn't film any of me pushing the buttons on the Metrel there.
Well, they want to see you push a button.
Yeah, it's all about using the tester, isn't it? To find your fault. I'm expecting to find. Well, this is part of the fault finding, Nigel. I don't know where I'm confusing you here. This is the instrumentation that we use for the job. So my connectors are on neutral earth, low impedance mode. So we're expecting to find a resistive short here, and indeed we do. Will you look at that, Mr. Marsh? 1.05 ohms. That's very low, isn't it? Interesting, Mr. Marsh. So what we've got to do now, we know we've got resistance. There's nothing we can do about this incoming current from the neighbours, but that's not going to cause us any trouble so long as we can clear off this problem here, this neutral earth fault of 1.04 ohms, because if we can get rid of that and get our insulation resistance numbers up nice and high again, then we can recommission all this and get that RCD stable again. But it's interesting to see that kind of high current on the incoming earth there. So this is kitchen lights. Let's have a look at this kitchen, shall we, Mr. Marsh? Oh, crikey. Getting up and down is getting tricky, isn't it? So we got downlights switched separately from pendants, switched separately from more downlights, more downlights, more downlights in the loo, wall lights, and an exterior light. Obviously the exterior light is always a good candidate for faults to earth, especially if the water's got where it shouldn't be, and there has been a lot of rain recently. We've already had off the light switch over here. It's a bit oversubscribed. but the neutrals are passing through the switch position. So what we can do is we can start breaking these circuits down at the switches to see if we can see what clears our fault. In fact, I'll tell you what we'll do. We'll use the Metrel MI3152 and we'll switch into continuity mode. Continuity, go.
Ooh.
That gives us a little audible beep. We've obviously got a neutral junction here. Oh, oh, oh.
Oh, there you go.
Hello, hello. Right, okay, well that's broken something down. That's the tester is now showing off scale high. So one of these is a feed-in. That's the feed-in because that's going to, it's all off, isn't it? That's going to the common position between the switches. So that neutral there is the feed-in.
Okay.
We know that neutral layer, or we suspect that neutral layer is going to the board.
Yes.
So one of these neutrals here, which presumably go out to the light positions, because there are 3 light positions, one of these must be faulty, and if we touch them, not that one.
Okay, which
Output on that one,
that
not that one. That's our scumbag.
can you see?
I can't see anything without my bloody glasses these days. That is going to... Christ, it's fucking busy in here. That is going to the 3rd switch, which I think is the kitchen down lights.
So that'll be these ones here.
We can test that theory, can't we? Because if I reconnect, I've already forgotten which one it was. That one. If I reconnect these 3 neutrals, but leave the kitchen downlights disconnected, then in theory, our fault should be clear. Tester says there's no short anymore. So I'm going to do something probably fairly naughty here and re-energise this while everything's still hanging out. But you know, Nigel and I, we're reasonably competent. We kind of know where we should and shouldn't be sticking our fingers, so hopefully we won't die.
Not far enough away that it's you that gets that.
The RCD's gone on without tripping.
Lovely.
Circuit's gone on without tripping.
Lovely. And there are
Dining room lights, pendant lights. WC lights and fan. Utility room.
outside light.
Yeah, outside light. All lights.
One of those, there's 2 ways for this.
And then you've got the 2-way for the kitchen light, 2-way for the dining lights, yes. So,
Okay, so
definitely
these are hot.
kitchen down lights. So what we're going to have to do now, of course, what we've got here, 2, 4, 6, 8 down lights, 9 down lights.
Yes.
We know we've got a fault on this cable, neutral earth fault. We can put our Metrel on there. In fact, what should we do? I'll do it up there. It's a bit of a shonky installation, this, isn't it?
Okay.
Yeah, okay.
Short.
So there's our fault at the switch position. What we're going to do now is break the circuit down. So we'll probably take out middle 2 down lights.
Well, if it's being fed from the switch, Take that first.
Well, it's either a fault between the switch and
The first.
downlight, or it's a fault between a section of downlight somewhere. As Nigel says, we'll assume that that's the first downlight position. It might not be, of course.
Usually nearest.
But we can open that up there and see what's going on there. There may be a junction box somewhere where we don't know if it goes, where the daisy chain's off, or whether these all spider off or what. But we'll have a look at that. We can split the circuit down into the middle, and check to see which half it's on, and then just break it down again, and let's do that.
Where's the springs? I don't fancy the mousetrap effect.
Always fun when the lights are painted or corked in. Yeah. Wow, okay.
Mind you, it's painted underneath, so I could probably just give that a check. Obviously,
we have warned the homeowners that there are the potential of damage to decorative finishes by our extracting of these things, but what can you do?
And look, the ring piece is falling apart. There we go.
Prem spec.
It's just,
well, for once, we've actually got the
yes, we haven't got
twin and earth inside the cable joint.
Well,
it doesn't look like a bad installation here, does it? It's a bit weird that personally, I don't know why they make boards like this where you've got so many circuit wires hanging off a bloody RCD. It's a bit ridiculous, isn't it? But, and there's a bit busy in there, the box is a bit inset. I'd have put a deeper box in myself, but it doesn't look.
Let's have a look inside.
It doesn't look completely cowboy. It's not like it's a builder's breakfast like we saw in another video recently. Anything to report, Mr. Marsh?
Well, the cable clamp is clamped down on a neutral here. As you can see, if you
oh yeah, they've caught the basic insulation in the clamp, and that's pretty tight on the clamp, isn't it? Might be worth loosening that off just to make sure nothing's been squeezed together there. So it's open circuit now.
Does it?
It does.
You can see there's some damage to the...
Yeah, it's hard to see, and there's a big ugly bloke behind, but you can see how the neutral's been squeezed there.
It's got a flat bit.
Done. Has did the line get squeezed onto it? In fact, is there any sign that it's been squeezed onto the CPC?
CPCs are all twisted together here. They pass between the core.
You haven't disconnected anything yet, then, have you?
No, okay.
And we're still on.
Nothing has been disconnected.
Fault's clear.
I wonder if they were being squeezed onto the CPC. I'm going to take this off.
Yes, Martian, let's have it off.
So we can,
Oh, David, it's your lucky day.
source it.
We'll see what's occurring. I'll tell you what, you'd be a jammy bastard if you found it on the first fucking downlight. Oh, he's a wanker, isn't he? We don't like him, do we, viewers? It's a bit shinky-shonky, isn't it?
I mean,
But
each person has got their own way of doing stuff.
And the thing is, this isn't an insulation resistance fault. It's not like there's some insulation that's just being overcome by the EMF we pump into the circuit. This is a resistive fault. This is something you can pick up on a friggin' ohm meter. So there has to be copper to copper contact.
That's been pushed in there. That's been pushed into the... Could that be it?
It could be it.
Let's get a torch.
There's a slight puncture there, but I don't know. It doesn't look like it's gone through, does it?
So look on this one, which has got more damage.
Well, I suppose pull back to good, re-terminate,
Well, if I pull it back a bit so I can see up the hole.
And then we can but test further. I don't know what we're going to do for the rest of the day if we found the fault already. It's only 20 past 10. We've already had a coffee. It's never a good idea to wrap those CPCs like that, really, is it? Not when they're...
Especially to do it and then clamp them in the...
Yeah, not when they're tight on the clamp to the other wires. These have got a 2017 date on them, so this... The work in here...
Less than 5 years.
Probably isn't all that old. I wonder when the kitchen work was done, when it was all converted.
Look at this, look at this. We use twin and earth in these. I know some people will use flex from a junction, but we use twin and earth, and a lot of people do.
Yeah, most people will use twin and earth.
And in twin and earth, the CPC is in the middle, yes?
You're not wrong, Mr. Marsh, you're not wrong.
And crossing it over can cause problems, as we've just seen. You'll get the earth crossing beneath. Look at this.
Oh, that's been made.
CPC line neutral. I thought someone had moved these, and I was about to move it back so that we had the CPC in the middle, and Dave noticed that it's labelled CPC line neutral. How bloody stupid is that?
That's an example of a manufacturer not thinking about how their product's installed.
So look, manufacturer Prem spec. Prem spec. Fuck you. Put it in the bloody middle, relabel it. Now, I've got a dilemma. Do I change that to where I think it should be and say screw you for the labelling, and expect that the next person that opens this is someone who knows?
Yeah, you know what? I say do that, because the legend on there isn't terribly noticeable, and it's quite obvious by the wiring colours what goes with it. If it makes for a better electrical connection on your wiring, then to hell with what the manufacturer has put on there. It doesn't really change anything electrically, does it? All you're doing is swapping around wires in the connector.
No, is this part of manufacturer's instructions?
Well, it's no longer as the manufacturer intended, one may argue, Mr. Marsh.
Yes.
But
when the manufacturer's a knobhead.
There is that. You have to account for manufacturer tomfoolery.
So there we go. Now, personally, I think I would notice these cable colours before I notice this black on black.
Yeah, someone in the future might take that down and go, oh, look at that, someone's changed how this is supposed to be wired. Probably be us, we'll be back here in a couple of years, we'll completely forgot we've done this job.
We'll be videoing it and go, oh, bloody hell.
We'll take it down and go, oh, look at this, some monkey, some kitchen fitter has taken this out and put the wires around in a different way to how the manufacturer intended. But then, you know, we say we're experts in anything. Don't do as we do, for fuck's sake. Don't listen to what we say. We're just muddling our way through the day.
In fact, it'd help if we undid these.
Do hurry up, Mr. Marsh, for goodness sake, you tedious little man. Just get the Metrel MI3152 ready for another resistance test. We're still good in the hood, so once Mr. Marsh reconnects this up, hopefully.
You know, these days I absolutely detest these plastic chop block connectors.
I quite like the old screwy chop blocks. Those push connectors you get on a lot of lights these days, I'm not such a fan, because sometimes you push your cable in, you think it's secure, and then you find that the old tug test, it fails a bit. You kind of know where you are with the screw connector.
Yeah, fiddling. Fiddling.
So I do quite like the screw connectors on downlights, but very few of them have them these days. I'll tell you what we had problems with the downlights recently. It's very boring, but while he's busy, we had to put some downlights in on an installation where they already had downlights, but there was no earthing on the circuit, and the downlights that were there were knackered, and we had to just try and do a light-for-light replacement. And we went to Cities, who used to sell these downlights made by ELD that were class 2, but had provision for earth, so you could loop in and out. And they no longer stock them, they've just got auroras on the shelf now. I know why they've done it, because the auroras have an interchangeable bezel, so you don't have to keep different stocks of different finishes. You can just keep one stock of downlights and then the different sort of bezels. But the trouble is, they're all class 1. And we were looking at elsewhere, electric, fixed, tool station, everywhere just seems to be class 1 downlights. But there are loads of installations where you need a class 2 fitting, so I had to order them in, which pissed me off, because now I've got to sit on stock of the frigging things. He's confident because he's... Have you put the cord grip back on? You haven't put the cord grip on?
Put the cord grip back. There you go. What a fool.
But you are electrically connected, yes?
Yes. And you've still got no...
We've still got no fault.
Make sure you're a connection at the switch, just in case it's just so it's come loose.
No, I don't think anything's changed there. You get your cord grip back on and then we'll see by the time you've mangled those cables together. That cord grip isn't really made for 2 twin and earths either, is it?
I think it is.
You reckon?
They're made to go one on top of each other. The screws are long enough and it's got these...
No, fair enough, okay.
It's got these bits at the edge that go into holes.
I'll take it back, So it was just the previous guy had been a bit ham-fisted
We got a little
in his
bit,
effort.
but that's just colour on the surface. But there was like a burn mark looking. I'm going to show my torch up and see if there's something that might have caused that, or if it was just a plumber doing something and heated up a pipe that heated up the cable.
We had that on another job recently, didn't we? We first fixed our cabling and the plumber came along and mangled his pipework in there and brazed it all together and burnt our cabling.
Yes.
Cheers.
And that was a brand new cabling, wasn't it?
Right, you're back together.
We are back together. Like I say, I'm just going to shine me old.
Metro says we're good. So what I'll do then is I'll reconnect all that switch up and put the metal back on at the board position and test it from there.
There are radiator pipes up here, small ones, which is like how this was burned.
And we just need to make sure the cables go back in so that they are not
it's difficult.
subject to external influences.
I'll try and pull it off.
Right, so we're back together at the switch, we're back together at the lights. Nige thinks he's fixed the fault. Let's see, shall we? Well, bugger me.
No, thank you.
But to be sure, we need to IR test. So, line to neutral, test to earth. Insulation resistance, what are we on? 250 volts. Ah, that's interesting. That's throwing up its. I'm detecting a load below 50 kilo ohms here,
Yes.
which we don't want to be seeing.
Okay, so
The resistive fault's gone then.
we've got rid of the resistive fault, which is one step we need to investigate further on, don't we?
That ought to trip the RCD then, shouldn't it, if it were reconnected?
It ought to, yes.
It ought to. And it does. One fault down, another fault to go as it turns out. How annoying. But it goes to show that if one of those downlights is terminated in that sort of way, then the rest probably are as well. Then we're probably looking for the same thing again, where we got the inner cores of the insulation squished together. Previously, the copper must have been in contact for us to have got a resistive fault. Now we're looking for something where we don't have a proper copper-to-copper contact, but what we do have is a compromise of the insulation where the two cables have been squeezed together so much that there's hardly any insulating material between them, and when we apply an EMF it manages to pass between live parts and Earth. 8 downlights that we haven't looked at yet.
Let's do it.
What are the chances it's going to be on number 8 after we've extracted them all?
Cool. Which one are you going to do last? And we'll start with that.
It was going too easily. Yeah, we want to pick the last one, don't we? I mean, we can, of course, do what we said earlier and take down a middle one to presumably, and we don't know how they're wired,
We'll split it. And
presumably break the circuit down, do the IR test again, and that hopefully will give us a half to be working on. Seeing as you did one, I suppose I'd better show some willing.
what we got there? Is it on the cabling again?
Yeah, same sort of thing again. Not so bad this one, I don't think, so I don't think the fault's going to be here, but
Yeah.
what we can do is break it down here.
Give it a split.
And again, as Nigel, it doesn't help that the CPC is having to cross one of the other cores to get to the outer position because of the way these downlights have been designed. If that had been the CPC terminal in the centre, you wouldn't have this issue where it's crossing at the entry position and being crushed against the cores. Right, so we are
Split it.
we're split there. Let's see if we've still got the fault showing.
Okay.
I mean, for all we know, these just carry on down and then back that way, but
Yeah. Can you see which direction those cables are headed in? Yeah, headed. Yeah. So let's assume they've done the zigzag down the room bit.
that one's awkward to get to,
Because the joists go this way, don't they?
comparatively speaking, so let's move on to at least the easier ones. Obviously we can do some continuity testing to find out what goes where if we need to. Again, this one doesn't look like it's going to be the cause because the cord grip is on. I'll say that. Yeah, the cord grip is on the outer insulation. Let's move on to that one. That one's not so well done.
Yes.
Definite pinching gone on there.
See, I don't like this twisting together of CPCs. I understand the argument, but what it means is if the terminal comes loose, then at least your CPCs are still in contact and you've still got the earth continuity. I understand that.
Let's test that again.
You've done your bloody terminals up right in the first place. Shouldn't go under. What do we have? It's still showing that.
That's looking better. 102. But we can repeat our IR tests here. That's the reading we just got from the board end, so this is going back to the board.
Yes.
Whether it's going back via any of the downlights, I don't know, but that's our feed in. What have we got on the second cable?
You should put the strap on that testing.
Straps. Straps are for girls. Oh, that's bombing straight. Is that resistive again? That's got to be resistive. Bombing out that low. It is. 0.37. We're getting a resistive short again. What the fuck?
Okay. On that one. on that one. Okay. Right.
Good pinching going on here. In fact, I'll tell you what we'll do. Before I disconnect that, let's put our bleeper blooper back on here.
Because it does that.
And we'll just see if that stops when this one comes apart.
Oh, stopped.
So we are going via this
We are.
downlight. Again, the CPC twisting is quite severe, and it's right at the point where it pinches under the clamp. Might even have to cut that off. I don't know if I can even unwind it. No resistive short neutral earth there. That's going to be all right.
Yeah, no message. Okay.
So let's test that back at the beginning again. And we've got the failure a moment ago. That's going to be good again. So it looks like it was that one over the sink.
Yeah.
The thing is,
If you look at that for damage, strip it back, reconnect the light, test again.
yeah, we'll do that. The thing is though, I know you said about it being the last one you look at. You probably have to take all these down to double check them because they're clearly not terminated very competently. And even if you get it working today, whether any of the remaining ones will still be working next week is another matter. So I think they're all going to have to come down, all the terminations checked to make sure that the clamps aren't squashing the inner cores, just so that we can have some confidence that when we fix this fault it stays fixed. But let's get that one re-terminated. We'll get that one back on as well. In fact, we'll get them all back on to this point and see what the IR is doing at that end.
Yeah.
Nigel's just terminating the last of the 5 on that half of the room. The rest of them we've re-terminated, and on all of them we've relocated the earth wire to the middle, just so that the cables can more naturally sit in them when you're not trying to cross the CPC across the other cores, because that appears to be what the problem is here. It's a combination between manufacturing idiocy and lack of forethought, and an installer who's got a bit twisty with his cables to make them a bit too meaty at the points where he's clamping down on them. So by moving that, yes, it does alter the legend there, but that's not terribly noticeable. Anybody with half a clue wiring this up ought to be able to tell really what goes where. I mean, you can argue amongst yourselves about whether we've done the right thing now or not, but electrically it just makes for a more natural position for those cables to sit in, where they're not going to get in the way of each other so much. This thing always makes a noise when I start recording. Oh, that's all right. That's the lady for Thursday's job asking if we can do it Thursday. Yes, we can. I haven't actually told her yet that we're there Thursday, but there we go. So, yes, a little bit of a modification we're making there to the downlights for what ought to be a better condition for the wiring to sit in. But once Nigel's got those 5 in, or those 5 reconnected, and he's on the last one now, we'll do another IR test. And we were getting, on that first wire, the first downlight, 100 mega ohm. So hopefully we'll still be seeing something nice and high there. But that still leaves 4 downlights here that I think we're going to have to take down and check.
I think I prefer downlights that have the connectors, you know, the blue connectors.
I like the click connectors.
They're better because you've got such a tiny space between the gripper and the terminals in this. That's what makes installers end up sticking them in the gripper.
Nige. Sticky gripper up your shitter.
Is that your new catchphrase?
It'll do. Right, IR. Line neutral to earth. Fat 0 last time. What are we getting this time? 97.7. Lovely. Now, that's 97.7 without us having monkeyed with the remaining 4 lights. I think we should check the remaining 4 lights, because out of these 5, I think all of them have
re-terminated.
Yeah, well, they've all been re-terminated. There was only one that was perhaps not so bad, which was that one there. So I do wonder whether if we re-terminate those 4, whether that 97.7 will rise even further.
Yeah, maybe.
But we're going to have to check, aren't we? Because although 97.7 has a nice fat pass, and that these lights will now work without tripping the RCD, I'm sure we don't want to be called back in a couple of years to the same sort of fault again, because the trouble with this sort of thing where you've got cores squished against each other is it can take time for them to break down. So if we don't fix it now, it might be problematic in the future. But as an experiment, let's see what happens. 97.7 is our number. Let's take these 4 down, re-terminate them, see if we can get it higher. If we can get it higher, brilliant.
Let's do it. Yeah, you see, now if you looked at that without seeing that, you'd say, oh, that's quite well terminated, that's inside, you know. They look well terminated. It's only when you see this where you can see they're pinched in between.
And again, that CPC is going to be crossing the line there, and we know that they're wrapped together. If you want to take that apart, we're running out of space in this memory card.
Again, click connectors, you have more space. I just think they're the better way to go.
Yeah, so that's been squished against the line there, hasn't it? Because it's crossed again.
Yeah. It's crossed, and you can see the flattening on the neutral.
And I think we've re-terminated all but the last in the chain, which was the only one that looked like it was okay. What did we get before? 97.7. Let's see if our remaining efforts on the other units made any difference at all to that. About the same. But good enough for me, because that ain't gonna trouble the RCD, is it, Mr. Marsh? I think one of us has worked very well today and deserves to be bought a coffee by the other. What do you think, Nigel?
I think I agree. Thank you very much for the compliment.
And the lights are on.
Without tripping.
But is anyone home? Of course they're not going to trip. Not at 100 megaohms. Look at that, 100 on the nose. And that's at 250 volts. I didn't test it at 500, but never mind. Would have been about the same, I'm sure. Right, let's get these bad boys back in the ceiling, Mr. M.
Let's stick them in the hole.
Back in business. All the lights are on. And the world is a slightly safer place once more, Mr. Marsh. So, all down to a bit of a design flaw with the downlights, in our opinion, and a bit of overzealous cable tightening. But it goes to show that if you have that sort of thing, it can take some time for it to develop, and we think This was done in 2018, we think, all of this work in here.
Yeah.
So it's taken about 3 years for the insulation where it's been pinched to finally break down and cause trouble. Right, I don't think I've lost any bits of this metal so far. So, time for a coffee that you were going to buy me. What I find one of the biggest pain in the arse about this job, Mr. Marsh, is the scheduling.
Yes.
And the trouble with a fault-finding job is you never know how long that job's going to take.
No. Could be 5 minutes, could be 5 hours.
Yeah, you just don't know if you're going to be stuck there all day or not. So you book that in the morning, and then you get the job jobbed, as we indeed have. I don't know if any of this come out in camera, it might all be in silhouette, because we've got the sun behind us. Never mind. So you get the job jobbed, and then you think, right, okay, I've got to find something else for the afternoon. There's so much on the to-do list, but there's never anybody sort of available
On a Tuesday especially.
yeah. when you happen to need them. Yeah. So anyway, that's all part of the pain in the arse of running the business. But time for a coffee in the sun, and then we'll find something to do for the rest of the day. Maybe we'll just stay here. We should get on the lager. Oh well, see you next time.
On the Jack Daniels.
Fucking A.